So can you guys on Zoom hear me?
Yes.
Inside.
One of those days.
All right, good. Okay, so let's get started. So before we begin, let me tell you something. You should have seen this already while doing the homework. Whenever you solve a problem, make sure that you give the correct answer, okay? And if you're going to approximate your answer at the end, if the question does not tell you to approximate and you do, you need to provide at least 4 or 5 decimal places. Otherwise, it's going to mark it wrong for you, okay? For example, if the answer is 1.33333 and you write 1.3, it's going to say it's wrong. Instead, you should write 1/3 or whatever 1.333 is, okay? But if you don't want to write the exact answer and you give a decimal, make sure that you give 4 or 5 decimal places, okay? Otherwise, you get points taken away. Unless the question says approximate 2 decimal places, then that's a different story. So just keep that in mind. Okay, so last time we did a brief introduction to, just recall on some of the stuff that you saw back in Calculus 1 about integration, fundamental theorem of calculus, and so on. So now let's use these ideas for this topic, which is let's investigate integrals that result in inverse trigonometric functions. Okay, so how do these integrals look like? And let's practice the techniques on how to solve these integrals. So for this, let me remind you of the derivative of the inverse trigonometric functions, because remember, each derivative rule has an integral rule, right? So recall. And here I want to discuss derivative of inverse trigonometric functions. Now, it is enough to only remember those for inverse tangent, inverse sine, and inverse secant, okay? Because the other 3 are very similar, you just put a minus in front. You rarely will need to use inverse cosine, inverse cotangent, or inverse cosecant. So I'm gonna just remind you of the first 3 that I just mentioned. So first, let's take a look at the inverse tangent. I'm going to, in case that you don't remember the formula, I'm gonna show you how is it that we obtain something like this, and then we'll do a similar process to obtain the formula for the other 2. I will just give you the formulas after this, okay? But we do a similar idea. Let's derive the formula for inverse tangent. So let's say that we have a function y equal inverse tangent of x. Now, what does this mean? Remember, this is the inverse function of tangent. So this means that if I do tangent of y, I get x, right? That's what it means. So this means that if I do tangent of y, this has to be equal to x, right? So we are after the derivative. So what I'm going to do is I'm going to apply the derivative with respect to x. And then on the left-hand side, we're going to take advantage of the chain rule, okay? We're going to do implicit differentiation. So now I'm going to take derivative on both sides. Derivative with respect of x equals derivative with respect of x. So now on the left-hand side, notice that this is a composition. We have the tangent function together with the y function. Y is a function of x. So when you do derivative, this is going to be secant squared of y times dy dx. Remember this? That's implicit differentiation, okay? Which is just a fancy name for the chain rule, the composition. And then on the right-hand side, what's the derivative of x? 1. Good. So that's equal to 1. And then from here, it follows that dy dx is actually 1 over secant squared of y. Yes? Now, we have 2 choices here. We can play with identities, or we can use a little triangle to figure out what this expression is. I'm going to show you both ways because the triangle is helpful for the other formulas. But here, the identity actually is pretty nice. And we discussed this last time. Remember, secant squared is tangent squared plus 1, right? So this is the same thing as saying 1 over, I'm going to write as, it doesn't matter, but I'm going to write as 1 plus tangent squared. And why am I writing like this? Because we know what's tangent. What's tangent of y equal to? It's right here, right? It's equal to x. So we get dy dx. So derivative is 1 over 1 plus x squared. Do you understand this? Again, tangent of y is equal to x. An alternative way of doing this is via a triangle, and we're gonna need this approach later on. So let me remind you of this. So how can we obtain this formula from the triangle? Well, let's take advantage of this. So we have the tangent of y is equal to x. So that means y is an angle. So you may assume, remember that here the range of inverse tangent is quadrant 1, quadrant 4. Okay, so it's from negative pi over 2 to pi over 2. So that means y is either between 0 and 90 or the negative version of that. Okay, so it's okay to say that y is an angle in this triangle. Assume it's in quadrant 1, for example. All right, I'm going to put y here. And we know that tangent of y is equal to x, so tangent is opposite over adjacent. So that means in this triangle, this guy is x, and this one is 1, right? Because you can think of this x as being x over 1. Okay, opposite over adjacent.
Excuse me, sorry, Professor. I thought classes started at 40.
It starts at 10.
I apologize.
So, don't worry. Yes, and now how do we find this side? What do we do? How do we find the hypotenuse? Pythagorean theorem. What is it?
X squared plus 1 squared equals the hypotenuse.
So then we take square root, so we get square root of 1 plus x squared, right? So now we can use the triangle to directly replace here what secant is. So looking at the triangle, from here we get the secant of y. Remember, secant is adjacent, is hypotenuse over adjacent, right? Secant is 1 over cosine. Cosine is adjacent over hypotenuse. So secant is hypotenuse over adjacent. So we can see from the triangle that secant is 1 plus square root of 1 plus x squared. If you put that in here, when you square, the square root is gone, and we get this formula. Okay? So there are two ways of getting here. You either use an identity, or if you don't want to use identities, you can use a triangle. Okay? I'm bringing the triangle up because we're going to need this later on. Anyways, yes?
Where did you say you got the secant y equal to?
Look at the triangle. What's secant equal to? That's hypotenuse over adjacent, right?
Right.
So hypotenuse is square root of 1 plus x squared, and adjacent is equal to 1. Everybody okay with this? Okay, I mean, the bottom line is that this is what you need to remember, okay? Derivative of the inverse tangent. I'm just showing you why is it equal to that. So we have, let me summarize the formulas. Derivative of inverse tangent is 1 over 1 plus x squared. Then we also have the derivative of the inverse sine. We play a similar game like the one that we did above, but then we get a slightly different expression. We get 1 over square root of 1 minus x squared. Again, all of this is the result of doing Pythagorean theorem. Okay? So we use the same idea to come up with this formula. And then finally, the derivative of inverse secant. If you remember from Trig, this is the one that is a little bit more involved. And you're going to obtain 1 over absolute value of x times square root of x squared minus 1. Okay? Because here you need to split the work by cases depending on the quadrant, and then you can put the two formulas together because one is positive and the other one will be negative. But with the absolute value, you'll be able to get rid of both, to combine both formulas into one. Anyways, these are the derivatives of the inverse trigonometric functions, and now each of these will give you an integral formula, right? So let's write them down. So we have theorem. Number 1. We have the integral of 1 over 1 plus x squared. This will be equal to the inverse tangent. Remember that an alternative way of writing inverse tangent is arctangent, so you may see that. So sometimes we also write this as arctangent of x. Okay, so it means the same thing. And instead of inverse sine, you can write arc sine. Instead of inverse secant, you can write arc secant. Okay, it's just different notation. Then, if you have the integral of 1 over square root of 1 minus x squared, you know, that's the result of doing derivative of inverse sine. So if you integrate this, you get back your inverse sine. So this is inverse sine of x. And then finally, the integral of 1 over x square root of x squared minus 1 is inverse secant. And then this time we put the absolute value here. Okay? And proceed as just your constant of integration. Now we're going to do examples with this. But any questions on these formulas? Are you okay with this?
Is it required on the secant to put the absolute value on?
Yes, so you should put the absolute value here. Yes. Questions? Okay, so then let's do examples. So examples. So evaluate. And let's see, let's use this idea to calculate the following integral. 1 over 2 plus 9x squared. Let's try to evaluate this integral. All right, so how do we do something like this? Anybody has an idea? What do we do here? Yes?
Couldn't you find u for 9x squared? Or couldn't you divide into a and u? Where a is just the constant next to.
What do you mean by a?
As a random variable to represent a constant.
So are you using a table of integration? Is that what you're telling me?
I'm using the formula that was given to us.
Yeah, well, you see, the problem about memorizing those things is that then what if you don't remember the formula or you forget? So I don't like that. So, I mean, if you trust your memory, that's fine. I do not recommend that because if you forget the formula, if the a goes in the numerator instead of the denominator, something like that, then that's it, right? Mm-hmm. So the idea is, okay, how do we solve this? It's really not that bad. Of course, if you know the formula, then you just get it in one shot. But if you don't, then it's just a couple of steps. So first of all, from these three integrals, let's try to see if you identify which one do you think this one belongs to. Among the three types, which one do you think this is? They are tangent, right? It has a form 1 over, so a number over a number plus something squared, right? This is really overlooking. A number over a number plus something squared. Now, our job is to play with this and make this look like number 1. Once this looks like 1 over 1 plus something squared, and of course that something will be a substitution and so on, then we'll be able to say, okay, it will be arctangent of whatever. You understand this? So, but I know this is an arctangent integral. It's not this, it's not this. It has the shape of number 1. So I'm just gonna modify this function to make it look like that, in that form, okay? So we already have a 1 in the numerator, so that's good. The next thing that I want to do is I want to get rid of this 2. I don't like that 2 there. We need to have a 1, okay? So what we can do here, that's really not a big deal. We can just factor out the 2, and then we're going to have a 1/2 here that we can take it out of the integral, okay? So I'm going to factor out 2 in the denominator. That's the first step. And the reason is because, you know, get a 2 down here. By factoring out the 2, now I have a 1 in here, okay? You need to divide by 2 here because I factor it out. And now that means that I have a 1/2 here that I can take outside the integral. So this now becomes 1/2 the integral of 1 over 1 plus. And now, okay, I'm going to, don't copy this second part yet because I'm going to rewrite it, okay? But just to show you how it's looking so far. Actually, if you want to copy it, I'm going to do a new line. Once you get practice with this, then you can do several steps in one. Okay, do you understand this so far? So I have my 1 in the top, I have my 1 here, and my plus. All I need is now to work with this little term, this fraction over here, and the job is that I would like this to be something square. That's what I want, okay? And then once we can do that, then we will be able to make a substitution, u equals that something, and we're going to have exactly this form, 1 over 1 plus u squared. Do you understand this? So how can we do that? So what should I put here? 3x.
3x over
Very good. Don't forget the 2. Yes? So 9 is 3 squared. X is well, x squared. So we can put a 3x in here. Now we just need to do something about this 2. We can put it over square root of 2. Yes? Because when you square it, you get that guy. So I'm going to rewrite this as 3x over square root of 2 squared. Do you understand where this is coming from? Because remember, I want to have something squared. So how do you make this something squared? Just take square root of everything that you see here, right? That's basically what you do. Take square root of every single term, and then you put inside the parentheses, and you square it back. Are we okay here? Okay, so this is my u, okay? I'm gonna make a substitution now. Let me rewrite this, as I said. So this is 1/2, 1 over 1 plus 3x over the square root of 2 squared dx. And now I'm going to make my substitution. So let u be 3x over square root of 2. So that means that du is going to be, what's the derivative of this? 3 over the square root of 2 dx. And now, so I already have a u for here. Now I just need something for dx because there is nothing else going on. So I'm going to solve for dx here. Okay. So this tells me that dx equals square root of 2 over 3 du. Okay. So now we go back to our integral and we put it. So this is 1 over 1 plus u squared times, and then dx is square root 2 over 3 du. Now, square root of 2 over 3, that's a constant, so I'm going to take it out, and then we get 1 over 1 plus u squared, that's inverse tangent, right? So this becomes square root of 2 over 6, because that's 3 times 2, right, outside. Inverse tangent of u plus c, and then the original variable was x, so you just need to put back whatever u was equal to. So then this is square root of 2 over 6 inverse tangent of 3 over the square root of 2x plus c. All right, questions? Any questions on what we did?
Yeah.
Yes.
I'm just confused about why multiply dx, they're not du, or du by dx.
Say that again.
So over there you multiplied.
You mean here?
Yeah. Here you did du and dx, and it shouldn't be multiplied by du by dx.
So again, I'm just doing a substitution. I'm just doing a substitution. Okay. Yeah. So this part right here inside the parentheses, that becomes u.
Yeah.
Okay, up to here.
Yep.
Now I just want to see what this is. What's dx?
Okay.
So then here in our substitution, we have that du equals 3 over the square root of 2 dx.
So we found dx.
Solve for dx, because that's what I need, right? I need dx. So dx is square, so just multiply and then divide by 3. So square root of 2 over 3 du, that's what I put here. So this is my dx right here, square root of 2 over 3 du. Yes?
Yeah, got it.
Yes. What I'm trying to tell you is try not to memorize. I mean, the thing that you need to memorize is the fact that if you see this is our tangent. This is what you need to know. Okay? But other than that, just play with expression. Because you memorize a formula, then there will be 20 formulas you will need to remember. At some point, that will be an issue. So it's better to be able to play with this and do it. Okay? All right. Any other question? Do I need to explain anything from here?
That's how we write the answer.
Yeah, that's it, because it's an indefinite integral, right? So the answer is a function plus a constant. Remember, always go back to x, okay, to the original variable. Are we okay? All right, so let's see. Let's do another one. I mean, we're going to do several, but how about this one? Integral of x plus 2 over square 4 minus x squared. So let's try to have a plan. So remember, when you see an integral, instead of writing stuff down, you should make a plan first, okay? So any ideas? What can we do here?
We can use the second rule and try to make it match that.
Okay, but the second rule, again, let's see. The general pattern of the first one is number over number plus something squared. That's the general pattern of the first one. Now, the general pattern of the second one is number over square root of number minus something squared. Okay, but notice that no variable on top, you need to have a number, right? In this problem, we have a variable in the top. You are not far from what we need to do, but it's not just number one. There's something else that we need to do.
So maybe we like move it downwards, x plus 2.
How are you going to do that?
1 over x plus 2 to the power negative 1 times that.
Okay, you're going to make it more complicated. If you do that, you make it more complicated.
Could you substitute for x plus 2?
You can substitute for x plus 2, but that's not going to get rid of the variable on the top. You'll just be putting a u in here, for example. But you're not going to get rid of it.
Would you split it into two fractions?
Good. So, like your two classmates are saying, what we can do is, look, I can split this into two fractions, right? The first one, we can do it easily. How can we do the first one? So when you split it, you're going to get this integral, x over square root of 4 minus x squared. How do we do that one?
You can use u sub for that one, and then for the other one.
Exactly. We do a u sub. We let u be 4 minus x squared, and then everything will work out nicely. Yes? And then for the other one, we're going to have number over square root of number minus something squared. That is where arc sign comes into play, inverse sign. Do you understand the strategy? The split, the first one is a u sub, the second one will be an inverse sign that we need to fix it before we can use it, like what we did for our time. Yes? All right, so as a strategy, let's go for it. So I'm going to split this. We're going to get two integrals. First one is x over square root of 4 minus x squared dx, and plus the other integral would be 2 over square root of 4 minus x squared dx. Are we okay here? All right, so, and just so we don't have too many stuff going on, I'm going to take the first integral, calculate it, then I'm going to take the second integral, calculate it, and then we put the answer back, which is the sum of the two. Okay? So, let's call this one integral 1, and this one will be, of course, integral 2. So let's worry about integral 1 now. So that's the integral of x over square root of 4 minus x squared. And like most of you pointed out, all we have to do here is a little u sub. We let u be 4 minus x squared, and we'll be able to do it like this because your du is negative 2x, right? And we already have an x in here. We just need a negative 2, but that's pretty easy to deal with. When you're off by a constant, that's not a problem. So let u be 4 minus x squared. So that means that du is going to be negative 2x dx. I already have x dx in here, and here is my x dx, so I'm going to divide by negative 2. You understand this? So divide by negative 2, so we get that x dx equals du over negative 2. Now we go back and we substitute. Okay, so this will be 1 over square root of 4 of square root of u, and then x dx becomes du over negative 2. Are we okay here? All right, so what do we do now? How do we go from here?
You factor out the negative 2.
Take out the negative 1/2. It's really a negative 1/2.
Yeah.
And then we did this last time.
You would turn then you would take the integral of 1 over square root of u by putting it in the numerator by making it u to the negative 1/2 power.
You do a negative 1/2, and then we use power rule, right? So this is a power rule integral. Okay. All right, so we take out the negative 1/2, and then we rewrite this as u to a negative 1/2. Yes? Now, power rule. Remember, the power rule says that you just add 1 to the exponent. So we're going to get negative 1/2 plus 1 over negative 1/2 plus 1. So as negative 1/2 times u to the 1/2 over 1/2. These 2's here cancel out because this 1/2 in the denominator, that's a 2 that comes to the top, then simplifies with this one. Okay? So they cancel each other out. So we end up with negative square root of, so I'm going to put back x, okay? So u equals 4 minus x squared plus c. So this is what the first integral is equal to. You okay with this? Mm-hmm. That's the first integral. Okay. For example, remember, you can always take derivative to check. If we quickly take the derivative of this, what do we have? Remember, square root is 1 over 2 square root of x. So the derivative of this is going to be negative 1 over 2 this term times negative 2x. Yeah, times negative 2x. The negative will cancel out, giving me positive, and the 2 that comes from the derivative of the inside will cancel with the 2 in the denominator, leaving me with x only in the top. Okay? So that way you know that we did it correctly. All right, so that's the first integral. Now we need to go ahead and calculate the second integral. So now we'll calculate the second integral. That's 2 over square root of 4 minus x squared dx. Once again, we realize that this has the shape of an arc sine, right? An inverse sine integral, because it has the form number over square root of number minus something squared. So this has the form number minus something squared. So that means that this is an inverse sine integral. Okay, but before we actually see what inverse sine it is, then let's play with this a little bit. So again, when I say number, remember what we really need is we need a 1 in the position of the numbers, right? So we need to modify this first. Let's see, we need to put a 1 over here. How can we do that?
You multiply that 2 to the integral and you have a 1/2, like a 2 in the bottom, in the denominator. And you cancel it out together.
Ah, interesting. So you are working with it. That's good.
Okay.
Yeah, but you're working here then.
No, I mean, I'm working on the outside of the,
Why do you need a 2 in the denominator?
to cancel out. Because if I got a 2 in the denominator and I multiplied a 2 outside of the integral, then I can just cancel out the 2 in the top and just get a 1.
You can just take the 2 out of the.
Oh, for real? Well, I mean, it's the same thing.
Yeah, it's the same.
But it's just like, I just like, kind of like.
You are multiplying and dividing by 2, just take it out. Right?
But it's the same thing. Like,
It's the same thing.
Yeah.
You can just take it out, right? Remember, this is 2 times 1, right? Take out the 2 and the 1 stays. Do you understand this? But what your classmate is saying is, okay, multiply top and bottom by 2. It's just that the one in top, leave it outside, the one in the bottom, leave it inside. It will cancel. It's the same. But the point is that when we actually play now with the bottom to get a 1 here instead of a 4, another 2 is going to come up that will cancel this one. Because what I'm going to do, I'm going to factor 4, right? And then square root of 4 is 2. And that 2 will cancel with this one. But let's do this one step at a time. It just turns out, because it's nice, if this would have been a 9 instead of a 4, then it wouldn't cancel and we would get a 2 over 3. Okay? So, because of that, I'm just going to do the steps the general way. So, I'm going to take out the 2. And I did that so that I will have a 1 on top. Yes? Now, inside, we already know what to do. I'm going to factor out 4 because I 1 and 1 in there. Instead of a 4, I 1 and 1. Then, of course, you need to divide by 4. Now, I'm going to split the square root. Remember, square root of a product is a product of square roots. So that means this 4 comes out as a 2. And right now, you already know what we want, right? We need here something squared. What should I put inside the parentheses? X over 2. Good. Do you understand this? This exactly the same idea that we use above, right? Now, these two down here cancel with this one that we have outside. And it's now clear what substitution to make. What substitution do we need to make? So u equals x over 2, right? Or if you're feeling adventurous, you can immediately tell me what the inverse sign is in here, right? It will be inverse sign of x over 2, but then you need to take care of the chain rule, because the derivative on the inside will be 1/2, so you have to multiply by 2 to compensate, right? So the answer here will be 2 times inverse sign of x over 2. But let's do the use of. So if you still don't see it like that, then just do the use of. But for something like this, you may not need to use of, okay? Anyways, right now, I'm going to use of. So u is equal to x over 2, this guy right here. So du becomes 1/2 dx. But since I only have dx here, I'm going to move this 2 over here, multiply, which is the one that I was mentioning that you would need to do to compensate because of the chain rule. And now let's substitute. So remember, the 2's cancel out, okay? So we get 1 over square root of 1 minus u squared, and then dx equals 2 du. So we take the 2 out, and then we have exactly the integral of 1 over square root of 1 minus u squared, which is inverse sine of u. And then we put back what u was equal to. So this is inverse sine x over 2. So again, what I was saying earlier, now that you're seeing it, is that, you know, if you want to do this integral directly, you could say, oh, this is inverse sine of x over 2. But remember, you have to take into account chain rule. If you take the derivative of inverse sine of x over 2, you're going to get this expression, but then times 1/2, right? You need to get rid of that 1/2 because we don't have 1/2 here in the integral. And that's why you need the times 2 here outside. It's the same thing that when we had e to the 2x. What was the integral? E to the 2x over 2. You have to compensate by that times 2 that pops up. Same thing here. But if you don't see it, then just do the substitution, okay? It will just take you a couple more steps to get to the answer, but it's not a big deal. All right, so questions on the second integral? So now that we have the 2 pieces, we put them back. Remember, these are just in between steps. So now the final answer is our result from the blue integral plus the red integral, right? So this is now equal to, first one was negative the square root of 4 minus x squared
plus 2 arc sine of x over 2 plus
x over 2, and then, you know, the integral from one, the constant from one integral plus the constant of the other integral, that's just another constant, because everything is, these constants are arbitrary. Just put them together and call it c again. Or you could call this one c1, that one c2, and then c1 plus c2, but it doesn't matter. All right. Questions? Okay. So again, what I want you to get from this is the technique on how to solve this. So you have a general pattern, right? So a general pattern that you want to match before you calculate your integral. So then you need to play with the expression and do some algebra. That's what we did, right? So we did a bunch of algebra here, and then once we were ready, right here at this spot, we are ready because we have 1 over square root of 1 minus something squared. Maybe now you know exactly what substitution to make to have just u squared, so that then you can say, okay, this is inverse sine, right? That's what we're doing. Questions? Okay, so are you guys doing okay on Blackboard? Okay. All right. Let's see. Try this one out. I'm gonna give you, say, at least 1 minute to put your thoughts together, maybe write something down.
same one we just did, like the same form, that's gonna be arc sine, right?
Well, be careful. Arc sine is 1 minus 1 minus something squared, right? This one is something minus 1, right? So, by the way, do you see a square here? Yes? Say that again?
The secant,
But what's the problem with secant?
it doesn't have the absolute value as on the outside of the.
Well, it's missing the variable in here, right? I mean, also, you can say, well, it clearly is not a tangent. It doesn't seem to be our sine, so it should be our secant, right? So you can do it for process of elimination, but that means that you have to play with this first before you can even see the actual form. But before we get there, do you see a square? So remember, when you multiply two exponents, you can write this as the exponential of an exponential. So this e to the 2x, you can think of it as e to the x squared. Yes, because of the fact that you multiply exponents. So this is helpful to write it down. So let me write it down. You may want to rewrite this as square root of e to the x squared minus 1. Just to see it better, okay? So again, we don't go with the arc sine because arc sine you need to have 1 minus, okay? But that's not what we have here.
Can you explain that? How you went from 2x next to.
Oh, I basically use this property. So if you have, so recall a to the m to the n, when you have an exponent and then raised to another power, you multiply the exponents. This is a to the m times n. So we use it backwards.
Oh.
Because you have 2 times x.
Oh, gotcha.
So you can write as e to the x and then square. Okay, any ideas? Yes.
Well, can't you make e to the x the u?
Okay.
And then when you put u equals e to the x, then you put du equals x e to the x.
Okay.
And then e to the x equals du over x e to
Over
the
e to the x.
over e to the x.
Okay, let's write it down. So,
Okay.
but yes, you are on the right track. So the first thing that we're gonna do is let's make a substitution, okay, just to fix this a little bit, okay. In other words, I wanna get rid of this e to the x here. This is bothered, okay. So I want to get rid of it, but the problem is that we don't really have an e to the x. By the way, if we had an e to the x up here, that would be nice, okay, but we don't. But that's not a problem. Like your classmate is saying, we can still manipulate the expression a little bit. So again, let's make the following substitution. Let u be equal to e to the x. So that means that du is going to be e to the x dx. Yes? Now, I already know that this will be a u. E to the x will become u. But then dx, I only have dx here. So here is dx. I'm going to divide by e to the x. But you should not be mixing x's and y's, but x's and u's. But remember, e to the x is the same thing as u, right? So when I divide by e to the x, if you don't mind, I'm going to put over u. That's the same thing. U and e to the x is the same, okay? It's just that having u's and x in the same place is not good practice. So this means that if I do du over u, then I'm going to get dx. Do you understand this? Again, I just divided by e to the x, but relabel it as u because they are equal. It's equal to u, right? Okay, now we're good to go. So this becomes, let's see, 1 over the square root of u squared minus 1, and then dx is du over u. And now what is this integral? This is 1 over u times square root of u squared minus 1. And now you can say this is inverse secant. Okay? In other words, the inverse secant was kind of hidden behind this point. Okay? Sometimes you may need to do some voodoo to get it out and be able to recognize. Anyways, right now we don't even need to play with expression anymore. Now we can immediately say that this is inverse secant. of absolute value of u, right? But notice that u is equal to e to the x. E to the x is already positive, right? It's always positive, so we don't really need the absolute value for this particular case. So we can just say this is inverse secant of e to the x.
But if we were to put the absolute value, would that be wrong?
No, but
Okay.
it's like saying, instead of saying that your answer is 2, you're telling me that the answer is absolute value of 2. It's not wrong.
But let's say we don't like recall the moment.
Don't worry. I know, but but remember, every time that you want to give an answer with absolute value, you need to wonder yourself, the stuff inside, is it negative at some point? Because if it's never negative, why are you going to put the absolute value, right? You only put absolute value when you don't know, when your function may be positive or negative. But if you already know that it's positive, then you don't have to worry about it. Yeah. Also, remember, if the question is multiple choice, it may not show up with absolute value, right? in the exam, so you need to know, or there could be an option with absolute value and one without absolute value. So you need to know which one is.
Wouldn't do that to us.
Okay, questions? Yes.
If you were to do the derivative of that, like
Uh-huh.
the check,
Yes.
how do you get that answer? Because when I
Okay.
do it, there's a little ex in the bottom. So how do you get rid of it?
So did you use chain rule? Remember, times everything on the inside. You will get an e to the x in the top, and they cancel
That's
out,
my bad. I forgot.
right? So do you want me to do? I mean, you already, right? So chain rule. Remember, chain rule. Every time that you see a composition, chain rule. All right. Questions? Okay, let's see. Let me give you one for you to try. And then take attendance as you work on this one. Let's see, what are we expecting to get from here? Inverse secant, right? This is an inverse secant integral. Now you first need to play with it, right? You need to prepare it so then you can, make the right substitution and all of that business. So go for it. That's out of the way. Okay, any progress? Did you use a formula? No? Okay, good. Yes.
So does the top have to always be 1 at the top, or any number?
Well, if
One, right?
if you have a 1, but if you have a number, that's not a problem.
Yeah.
If you have a number here, you just take it out.
You just take it out.
Okay, so it's not really a
And
problem.
the one where it says,
So we want a 1. So we want something squared minus 1.
minus 1 has to be 1.
Yeah.
Okay.
For you to say that it's inverse secant, we need to have the 1 in here,
Yeah.
and then here a variable square, and then the same variable that you have here has to be outside.
Yeah.
Exactly this form. It's just that maybe not x, maybe u or whatever other variable. Okay. So first thing is that we're gonna modify this expression to make it look like that. Yes. So we already have the 1 on top. No need to worry about that. Next, we need to put a 1 here, right? Instead of a 9, we put a 1. So what do? Factor out a 9, right? So I'm gonna factor out a 9, and then we get 4x squared over 9 minus 1. Everybody okay with this? Mm-hmm. All right. So now we know that this 9 is gonna come out as a 3, and I'm gonna take So I'm gonna take the 3 out as a 1 over 3. Everybody okay with this? In front of the integral. So that's gonna give me a 1 over 3. And then down here we have x. And let's see, I want to have something square. What should I put inside the parentheses? 2x over 3. Good. Does everybody understand this? Yes? Yeah. Why is this relevant? Because now this is telling us exactly what substitution to make. Okay? Let me put my dx in here. So what should be our substitution? So we're gonna call this guy u, right? So we're gonna let u be equals 2x. So du 2 over 3 dx. Now, once again, we only have dx in here, so I'm going to go ahead and solve for it. Okay? So dx is equal to 3 over 2 du. Okay? You could do that, or if you don't like this solving business, in this case, what you can do is, okay, I don't have a 2 over 3, but you can put it. But if you put it, then you need to compensate by putting a 3/2 outside. You understand this? They cancel out and give you 1. And then you can just go ahead and replace this by du. That's in case that you don't want to be doing this kind of stuff. Okay? But I'm gonna do that because if I start doing the other stuff, you will be asking me almost every day, where did that 2 over 3 come from and all of that business. So I would rather do this. Anyway, we are ready to do the substitution now. So let's see. dx, we know what happens. dx becomes 3/2 du. Now, x, what's x equal to?
3 over 2u.
Very good. So 3u over 2. Everybody see that? Because if u equals 2x over 3, then that means x is 3u over 2. Yes, so for x. And then here, this becomes u squared minus 1. And then nicely, this 3/2 here cancel with this 3/2 here. So we don't have to worry about that. So we get 1 over 3, the integral of 1 over u square root of u squared minus 1. And now we recognize that this is inverse secant, right? So this is 1 over 3, inverse secant of absolute value of u. And this time I'm going to keep the absolute value because u is a linear function. And as you know, this is sometimes positive, sometimes negative, right? So it really depends. Actually, for x positive is positive, for x negative is negative. Now, if this would have been a definite integral, let me put the final. So absolute value of 2x over 3 plus c. And if you are feeling fancy, you can just say that this is 2 over 3 absolute value of x, like taking the constant out. Now, I'm doing this because it's in an indefinite integral, but if it's a definite integral, let's say it was the integral from 1 to 10, for example, then you know that on that interval, this function is positive, so you don't need the absolute value, right? Anyway, your answer would be a number, so you will be evaluating those numbers anyway, okay? And you will realize that you didn't need the absolute value. But if it was from -2 to -1, then you will need the absolute value here.
So just to confirm.
Okay?
Just
Yes.
to confirm something. The reason that you got the 3 over 2 u in the bottom is because you're replacing x.
And literally
you're replacing-
substituting.
You're replacing x in the u equal to, and then in the top one it says you're replacing dx.
Yeah.
Okay.
You are literally substituting. So you go here and you say, what do I have here? dx, okay, what
And
is
you
equal
only
to?
do this with this one, with secant?
No, always. This is what substitution is. That's what substitution
Well, no,
means.
yeah, but I'm never gonna look at it.
Okay, but that's what substitution means. You make your substitution that you think is gonna work, and what does it mean to work? Well, it means that you will have a substitution for every single term in your integral. You need to change everything that has an x, now it has to have a u. Okay? So we go here, dx. What can I do with this guy? Well, I know that dx equals this. I put it. Then next, I have an x here. What do I know about x? Well, I can see that u is equal to this, so x is 3/2 over 2u. So I put it there. And this is my u, put it there. You're just changing everything. Instead of x's, now you want u's. That's all. That's why it's called substitution. Right? And the hope is that after you play this game, you get something easier, something that you can actually solve. Right? All right. Questions? Okay, so that's good. How about this one? Again, we already know the general form. Now I'm just showing you techniques of how to deal when integrals like this show up. Okay, but how about something like this? It's very annoying, the sound. Even more when the door opens. Yeah. They only have the signs pardon or dos, but they should also say and or noise or something like that. Okay, how about something like this? By the way, later on, we have a section that specializes on rational functions, how to integrate rational functions completely. Okay? This is a very special case, this one right here. So what can we do here? No, be careful. You can do that if you have the term in the numerator. For example, it's not true that this equals this. It's not true, right? Remember, if you add the right-hand side here, what do you get? As AB, and then that would be, so as B plus A over AB. Have nothing to do with 1 over A plus B, right? So what you can do is split it if you have the sum in the top. If you have this, then yes, you can do this. But it's different. We have that sum and difference is happening in the denominator now. So what can we do? Any ideas? Yes?
You just substitute the denominator for u.
Okay, but then what should be u? U will be 2x minus 4, right? But we don't have any x in the top to back that up. So it's not really going to help us. You can do it, nothing, but then you get stuck.
The only thing you can go to the product, but that's so complicated.
The quadratic formula.
Yeah, to like separate it.
What do you mean separate?
Like
Factor?
instead of factor, because I don't think you can factor it.
No, you cannot factor this.
Yes. So that's why. But I can't think of anything else.
So let's see. Because you cannot factor this, or if you want, by looking at the quadratic formula, you can look at the discriminant. So what's the discriminant of this? The discriminant is the stuff inside the square root in the quadratic formula. B squared minus 4ac. So that would be 16, right? Negative 4 squared. That would be 16 minus 4 times 7. So 4 times 7 is 28. So that's a negative number, right? 16 minus. So that means there are no real solutions to this. This is a parabola. This denominator is a parabola, and it doesn't cross the x-axis. Now, does it open up or down? It opens up, right? And it doesn't cross the x-axis. So that means something important. It means that actually this has this form, right? So it means that that's a parabola. I don't know where it is, but it looks like this somewhere. In other words, the formula, we can rewrite this as x plus or minus, it doesn't really matter, b squared. But then what's very important is that will be plus h. Maybe, well, in this case, a is equal to 1 because the leading coefficient form. So it will be minus if it's shifted to the right, it will be plus if it's shifted to the left. But what's important is that it's above the x-axis, therefore it will be plus h. You understand this? So what does that mean? If we and you know how to go from here to here. How is that process called from here to here? No. It's called completing the square. Remember completing the square? You learned it back in college algebra to solve quadratic equation, to deal with circles, and pre-calculus you did it when you saw ellipses and all of that business. So the idea here is that we're going to complete the square to make it look like this. The thing is that when you complete the square, you could get here a plus or a minus. Here we know we're going to get a plus because we're dealing with a parabola that looks like this. And why is that helpful for us? Because now this would be our tangent. We complete the square. Here we have to form a number over something squared plus a number, right? And then we'll be able to get an tangent.
So the variable h is just going to be another number? Is that what we think of it?
These are the coordinates of the vertex of the parabola. Yeah, this is the form of a quadratic function. This is the vertex, right? Whatever coordinates this point has, that's usually we use h and k. Let's see, put a b here, but maybe it's more familiar now. And you know, this is your h comma k. That's your vertex. Yes.
I don't remember. How do you tell if a parabola is point opening up or down?
Oh, if the coefficient is positive, if the leading coefficient is positive, it opens up. If the leading coefficient is negative, it opens down. So we know it opens up and it doesn't cross the x-axis, so it has to be up here. Yes? So I know I'm gonna get a plus. For example, if you had a negative in here, if it was negative x squared, that means that the graph would be like this, right? Or, well, I will have to change something because then the discriminant, let's see, it will be 16 plus. So I guess I will have to say like a -7 here or something like that, okay? But then the function will be like this, and so it means that it's not gonna cross the x-axis, but then you're gonna have a minus in here, okay? And with that minus in here, it would also work because this minus will give me a minus here, and you have a minus here. You can factor it out, and then you get your plus, so you have a negative beside the integral, and then you do a times. Okay. So when there are no zeros, it will be an arctangent. When the bottom has zeros, we're gonna do a special technique, which is called partial fraction decomposition. There is a section for that, okay, that we're gonna do in another chapter. But when the denominator is quadratic and it has no zeros, you can always do an arctangent by completing the square. That's the idea. Anyways, let's do it. So this is one more technique. Remember, you can complete squares, okay? Because after all, that's a way of turning a polynomial into something square, okay? That's what we're really looking for. So I'm gonna complete the square. So complete square. Let me do it here. So we have x squared minus 4x plus 7. So remember, to complete square, the first thing is that you need to have a 1 here as a leading coefficient. We already have a 1. If you add a number here that's not 1, you need to factor that first. And then you complete the square inside the parentheses. I already have a 1. So we just need to figure out what number do we need. So the question is, what do I need to have here in this blank so that x squared minus 4x plus something becomes a perfect square? Very good. So how do we find that number in here? We take this guy, divided by 2, and square, right? That's the process. So to complete the square, all you have to do is take this guy, that's -4. Then what you do is you divide it by 2 and you square. Okay? So in this case, we get 4. So that means that I need a plus 4 here, but I didn't have a 4. So if I add 4, what do you need to do? You need to take it away, right? I add 4, but then I also subtract. Do you understand this? Okay, so now this becomes, so x squared minus 4x plus 4, that is x minus 2 squared, and then 7 minus 4 is 3. So we get x minus 2 squared plus 3. Are you okay with this? All right, so let's rewrite this, so that then this becomes 1 over, I'm going to write it as 3 plus x minus 2 squared. And if you want, you can make a little substitution here, but then we'll have to do another substitution. So might as well just do it at once. Just remember, think of this x minus 2 as one thing. Okay? So now what's left is for us to factor out 3, right? To put a 1 in there. So I'm going to factor out 3. It's going to come out as a 1 over 3. And then, remember, you're going to have x minus 2 squared over 3. I'm going to write it already inside my big parentheses. And that would be x minus 2 over, what should I have down here? Square root of 3. Good. All right, let me explain what just happened. So once again, once you are here, then what is the technique? Think of this big X. If this bothers you, just call this U, because then you will have to make another little substitution. Okay? So what we need to do now is factor out 3 to have a 1 here. Yes? Because we're looking for 1 over 1 plus something squared. We need a 1 here, so you take out the 3. That is 1 over 3 that we have over here. And when you factor the 3, you have to divide x minus 2 squared by 3. But remember, you want to put that as something squared. So that's what I did here. And that's the reason why you have a square root of 3. You do this square, that's your over 3. And you factor. Okay? That's all. let's see, I see too many non-believing eyes, so let me draw the step. So as x minus 2 squared over 3. Do you understand this? After you factor the 3. Now let's write it as something squared. So that would be 1 over 1 plus x minus 2 over the square root of 3, all of that squared. We have been doing this for some time now in the previous 4 problems. So you should be comfortable with this now. And this is our substitution, right? So here is our substitution. So I'm going to let u be x minus 2 over the square root of 3. Remember, this is a line. This is 1 over the square root of 3x minus 2 over the square root of 3. So the derivative is just 1 over the square root of 3. Okay? So that means that du is going to be 1 over a square root of 3 dx. Okay, let's put the substitution. So that will be 1 over 1 plus u squared. And then who can tell me what's dx equal to? Square root of 3 du. Right here. Right? So for dx, multiplied by square root of 3. So we get the square root of 3 comes out. So square root of 3 over 3, inverse tangent of u. But remember, u is x minus 2 over the square root of 3. All right. Questions? So the bottom line here is that you can complete the square so that then you can use these techniques. Okay? That was the point of this problem. Questions? Yes?
Would that be correct as a final answer, or would we need to cancel that, cancel that, the coefficient next to tangent, right?
This one?
Right?
So
that can reduce?
You mean 1 over the square root of 3?
Yeah.
But technically, that's not simplified because remember, we don't want radicals in the denominator. So when you rationalize, this is what you get. But if you put 1 over the square root of 3, it's not wrong. It's perfectly fine. But I don't do it because technically we don't want square roots in the denominator.
So it's improper, but still correct.
Yeah, exactly. Okay. Questions? Yes.
Sorry, I'm not too sure about 3. The root 3, how you got root 3 over there. And
Do you understand?
1/3 out. Yeah, up to there, I get it.
Up to here?
Yeah.
Okay, now, again, look here. What are we trying to get? We're trying to get, we already have a 1 here in the numerator, a 1 here. We just want something squared, right? Right now we have something squared over 3. That's not good. We want something squared. So I need to get that 3 inside the parentheses somehow. So how do you write 3 as something squared? There you go. That's your answer. That's all I did, right? So this 3 is outside the parentheses. I want to get it in there. So we can get it in there as a square root of 3. That's all. Yeah. Yeah. If you have never seen this, it may take you a couple of problems to do on your own until you actually. And it's really not that bad once you get used to it. You have to get used to it first. Just always remember, we're trying to get 1 over 1 plus something squared. That's all we are trying to get. Yes? All right. And I guess to close this, let me do one that's a definite integral with limits of integration, because everything we have done is indefinite integral. So how about, so starting next time, we're going to look at applications, okay? We're going to look at area between curves, and then we're going to start looking at volumes, okay? So that's what we're going to be doing next week. So integral from 3/2 to 9/4 of 1 over 3x minus x squared. Okay, so in here, again, it may not be clear what's happening here, but we can actually learn from what we did above. The idea is, let's go ahead and let's complete square inside the square root. And then, most likely, because we have the negative square in here, that means that this is going to be the inverse sign form, okay? But anyway, we're going to see it immediately as soon as we complete the square. So what I'm going to do right now is I'm going to complete square, okay? Why are we going to do that? Because, if you have something going on here, like x or something, probably you solve will do the job, but we don't, okay? So the hope is that this would be one of the three forms that we have above, but to really see it, I don't like that 3x, so we need to complete the square. So let's do that. Complete squares. So we have 3x minus x squared. The first thing I'm going to do is I'm going to rewrite this as negative x squared plus 3x. And like I said, the leading coefficient has to be 1, right? So need to take care of, get rid of that negative. So that's minus x squared minus 3x. And we're going to complete the square inside the parentheses, because this minus is going to affect everything we do. Okay? All right, so what do I need to add in here to make it a perfect square?
You need to add 3 over 2 squared.
What is it?
You need to add 3 over 2 squared.
Which is 9 over 4. Okay? So we add 9 over 4, but if we add it, we need to subtract it. But again, everything is happening inside the parentheses. Why? Because this minus is affecting all of that. Do you understand that? Okay, so that means that this becomes negative. Now inside the parentheses, this part right here is a perfect square. What is it? We already know that it's going to be x minus something squared. That something is actually this number divided by 2. Okay? So it's going to be x minus 3/2 squared, and then minus 9 over 4. That's 9 over 4 over. And now I'm going to distribute the negative, which will flip these terms. So that will be 9 over 4 minus x minus 3/2 squared. We okay with this? All right. So let's do our substitution. Let's replace the integral with that. So 3x minus x squared is the same thing as saying 9 over 4 minus x minus 3/2 squared. Now it's a little bit, there are already too many fractions and too many things going on. So I did not do that above, but I'm going to do it here. I'm going to make a little substitution just to clear the integral a little bit. I'm going to call this t, okay? Just to clear the integral a little bit. So I'm going to call this t. Let t be equal, you just need to keep track of all your substitutions, okay? Then dt is just dx. So my integral, let's call the integral I. So I now becomes the integral of 1 over square root of 9 over 4 minus t squared dt. So I just call this t, and dx is just dt. And then we need to modify the limits of integration. That's important. So let's see. When x is equal to 3/2, then t is going to be equal to 3/2 minus 3/2, which is 0. And when x equals 9 over 4, then t is going to be 9 over 4 minus 3/2. You multiply by 2, you get 6 over 4. So 9 minus 6 is 3. So you get 3 over 4, right? So again, how did I get this 0 and this 3 over 4? By putting the limits here in the substitution, okay? You put 3/2 here, you get 0. You put 9 over 4 here, you're going to get 3 over 4. Do you understand this? That's how you get this number. I don't even, since this is definite, I don't even have to go back to x. That's why I'm changing the limits. So you can make as many substitutions as you want. You don't have to backtrack anyways, as long as you change your limits. Okay, so now here we are in business, right? You can see it's going to be an arc sign, and to do it, what we need to do? We first need to factor out this 9 over 4, to put a 1 here, and so on and so forth. Yes? So let's do it. So inside the square root, I'm gonna factor out 9/4. So we're gonna get 1 minus. Now, I need to divide this by 9/4, but that's the same thing as writing 4/9. Yes? So 4/9 t squared dt. Now the 9/4 comes out as a 3/2 of the square root, but that's in the denominator, so that would be a 2/3 in front of, because it's 1/3/2. That's a 2/3. So I will be 2/3. And let's see. Can you tell me what goes inside the, what should I put here inside the parentheses? So what should I put here? Remember, look at this term over here, right? You just want to write it as something squared. So what's the something? How can you? 2/3 times t. Everybody see that? Okay. If you want to take anything home from today, is that little trick, right? Because that's what we have been doing over and over again, right? So as 2t/3. Everybody okay with this? So that's our next substitution, right? So now we're gonna make a u sub. So let u be equal to 2t/3. So that means that du is gonna be 2/3 dt. Notice how conveniently we have a 2/3 outside here. So actually I'm gonna bring it back in with this dt and rewrite as du. You understand this? I mean, you could solve for dt, then you get 3/2 and then cancel without and all of that big stuff. I'm gonna do that. So this becomes the 2/3 is going in, and then with the dt becomes du. Everybody see that? So that would be 1 minus u squared du, because the 2/3 gets paired with the dt. And now we need to once again fix the limit of integration. So when t is 0, let's see, who can tell me what are the new limits? What should I put as the lower limit?
0.
0. What do I put as the upper limit? 2/3 times 3/4. 3 is cancel. 2 cancel with the 4, so you get 1/2. Right? Remember, guys, you're in calculus 2. You have been doing this computation since I don't know when. Okay? So you have to get comfortable with this, because if you start writing down in a corner these things every single time, it's going to take you forever to do one problem. Right? You don't want to do that. So again, how do we get this? You put t equals 0 here, so u is 0. T equals 3/4 over here. The 3 is cancel and the 2 cancel with the 4. So you get 1/2. Yes? And now we have inverse sine of u from 0 to 1/2. So the answer is inverse sine of 1/2 minus inverse sine of 0. What's inverse sine of 1/2? So what angle do you know whose sine equals 1/2? This is one of the special angles. Remember, there are 3 special angles, 30, 45, and 60, that you need to know all trigonometric values, sine, cosine, tangent, and the other 3, and also the quadrangle, 0, 180, 90, 270, 60, and so on. This is one of the special angles. Which one is it? That's 30 degrees. Okay? Sine of 30 degrees equals 1/2, which in radians is pi/6. Okay, here you have to give the answer in radians. Remember, you need to know this. Otherwise, every time that a trig function comes up, you're gonna be a little bit lost. Okay? So inverse sine of 1/2 equals pi/6. If not, use your calculator. You have a calculator. Problem is your calculator will give you a decimal, unless you have a fancy one that gives you pi/6. So you need to know this. So this is pi/6, and then inverse sine of 0, that's 0, because sine of 0 is 0. Okay, So the answer is pi over 6.